Okay, hopefully you've already worked on these problems before you came and found this lecture video, or this answer key video, shall I say. Let's look at the first problem. Do you notice the denominators aren't the same? Okay, so what's your first goal? Get them the same. So I have a denominator of a 2, an 11, and a 22. What did you do? Good, you made them look the same. The 22 is the biggest of the three denominators. You know that's 2 times 11, right? Which means this 2 needs to get multiplied by an 11 so it looks like it, right? And this 11 gets multiplied by a 2 so it looks like 22, 2 times 11, right? Okay, which means the numerators have to get multiplied as well by the appropriate number. So let's look at this. Here we end up with 33 over 22n minus 8 over 22 equals 91 over 22. Excellent. Well done. Now, what are we doing next? Yes, we're taking this 8 over 22 and we're adding it to both sides because it doesn't have a variable, so it's got to go. And again, I'm going to write it off here to the side so it's a little nicer to see. So what remains on the left? Good. The 33 over 22n, because the minus 8 over 22 and the plus 8 over 22 drop themselves out, equals, yes, same denominator, I can add them. So you end up with 99 over 22. So far, so good? Okay. Now, you need to get rid of the 33 over 22, don't you? By doing what? Yeah, dividing both sides by it. Now, remember on the lecture video, do we ever really divide fractions? You're right, we don't. We end up multiplying by the reciprocal. So I could actually just do that right from the start here. Knowing I'm going to divide by 33 over 22, what happens if I just cut to the chase and say, hey, let's just multiply it by its reciprocal? Because don't the 33s drop? Don't the 22s drop? And I'm left with just an n on that side? Yeah, good, huh? Because I already know that I'm going to have to multiply by the reciprocal, so why don't I just do it from the start? Cool? Okay, which means on this side, I also have to do the same thing. I have to multiply by the reciprocal, which means the 22s drop. Agreed? I end up with 99 over 33, which gratefully reduces just to a 3. What do you think? How's that? Is that good? Okay, love it. Let's look at problem number 2. Problem number 2 is interesting because the numerator here is comprised of 2 terms versus just 1 term. That's okay. We're still going to start the same way. We're going to get the common denominator. And what's the common denominator? Good, 4, which means I have to multiply this fraction, top and bottom, by 2, so it's a 4. Yes? All right. So we end up with 3x plus 2 all over 4 equaling 2x over 4. Yes? Good. Now, here's a little bit of an alternative. Because to try to multiply this by its reciprocal like I did over here doesn't work because the numerator has 2 terms in it. So consider this. If these denominators weren't here, wouldn't this be a really easy equation to solve? So, how about, instead of multiplying by the reciprocal, how about we multiply by the common denominator on both sides? What would happen here? Yeah, 4s would drop. What would happen there? 4s would drop. What would the equation be now? 3x plus 2 equals 2x. Yeah, that's really easy to work with, isn't it? I agree. So now we simply have to get all our x's on one side. So what are you going to do? I am going to minus 3x here because the right side already has a single x, shall I say. These guys drop away. You're left with 2 equaling negative x. And then, good, divide by negative 1 on both sides because you're only supposed to have a positive 1 in front of that x, right? Okay. So you end up with negative 2 equaling x for problem number 2. What do you think? Okay, so notice, on problem number 2, I did the exact same thing as problem number 1. I got the common denominator. The only difference that happened here was since this had 2 terms on the top, I just got rid of the denominator first, quickly. I couldn't multiply by the reciprocal because there was 2 terms up top versus just 1 term. Got it? Okay. Let's look at problem number 3. Fractions. What's the first thing you're going to do? Yes, get a common denominator, which would be 10. Excellent. Way to go. Which means the 5 has to get multiplied by 2. But so does the numerator, doesn't it? Now, how many terms are in this numerator? Good, 2 terms, which means both of them need to get multiplied by 2. Can't just do it to one part of the numerator. You got to do it to the whole thing. Good? Okay. I should say with me. Okay. So, do your distribution. You get 4x minus 6 all over 10 equals 3. And you can put the x up here if you'd like. It's the same thing, remember? Over 10. Okay. This problem, is it like number 1 or number 2? It's like number 2 because I have 2 terms up top. So do you want to keep the denominators at this point or would it be easier to get rid of them? Good. Get rid of them because if they were gone, wouldn't you have a nice simple little equation to solve? So that's what I'm going to do. I'm going to multiply by 10 over 1, the denominator on both sides, because what will happen here? Yes, they cancel. Make sure you cancel them, because when your brain sees them canceled, it won't remember the 10 anymore. It'll be like, oh, the 10's gone. I don't have to deal with it. Yay! Good, and you won't do an accidental multiplication problem. On the left, what remains? 4x minus 6. On the right, 3x. And now this is a very simple problem to solve, isn't it? It's almost just like this one. This whole process on number 3 was just like the process on number 2. But I started all 3 of them exactly the same. I got a common denominator first. That's the key. And then you can decide where you go from there. Good? Okay, so let's finish solving this. What are you going to do on this one? Good, minus the 4x on both sides because the right side already has just the x. You're left with negative 6 equaling negative x. And good, positive 6 equals x because you divide both sides by a negative 1. Excellent. Are y'all with me? Okay. I have a couple more examples, obviously still with fractions. It's a little more involved, but it's okay. We can handle it. And you should have done it before you got to this video anyway. Okay, hopefully you've already worked on these problems. Let's see what you've done. Let's see if we agree. Let's look at problem number 4. All right, I'm seeing parentheses, which means I'm going to have to do a distribution problem, right? Okay, so on number 4 here, the first thing I'm going to do is I'm going to distribute this 2/3 into both terms of the parentheses. Parenthesis, which means you get 2 over 3x plus 2 over 3. So far, so good? Okay. And then on the right side of the equal to sign, I have got these parentheses again. And I have this multiplication problem between the 1/9 and the parentheses. So we're going to distribute. So here we go. All right, let's take a look. You get 1 over 9x plus, some of you need to put a 1 under that. So you do 1 times 4 and 9 times 1. Good? Okay. So here we are. Not too bad. No more parentheses. Looks a little cleaner. All right. But I've got fractions. And they don't all have the same denominator. And I want them to have the same denominator because, as we've already seen, it's a lot easier when they have the same denominator. Are you with me? All right. So what's the common denominator between a 3 and a 9? Yeah, a 9. Which means these two are okay. These two we need to adjust. So on both of these fractions, we have to multiply the denominator by 3, don't we? And if you do it to the denominator, you do it to the numerator. And here we are. All right, so let's see. What's the first one look like? Good. 6x over 9. You can write it that way. That's legit. Plus 6 over 9 equals, 1/9 x. And you know what? I'm just going to keep these the same. So let me do just a little adjusting so they look the same. Okay? So 6 over 9x. Sorry about that. Plus 4 over 9. Okay. Good. Excellent. Now, remember in the first 3 problems? We left the denominators there and we started moving everything around. And then in a couple of the other problems, problems 2 and 3, we actually got rid of the denominators altogether, didn't we? And it was a nice, simple equation to work with after that, wasn't it? So you do have options. But I'm going to be honest with you. Since the denominators are all the same, wouldn't it be nice if they were gone? Because I'd have a nice, easier looking equation to deal with. So let's do that. And here's the deal. What you do to one side, you do to the other. And what you do to one term, you have to do to the other term. So if I decide to multiply this entire side by 9 over 1, so I can get rid of those 9s, I have to multiply this entire side by 9 over 1, so I can get rid of those 9s. And this 9 is going to get multiplied to the first fraction, which cancels that 9. But this 9 also gets multiplied to the second fraction, which also cancels the second denominator of 9. Does that make sense? This one over here, this 9 over 1 gets multiplied to the 4 over 9, which cancels this denominator, but also gets multiplied to this one, which cancels this denominator. So all the denominators of 9 are going to drop out when you multiply both sides by 9, the common denominator, which means you'll be left with 6x plus 6 equaling 1x plus 4, which is built on what we did from the first 3 problems. What do you think? Does that make sense? Is that a little bit nicer to deal with than having all these fractions with 9s under them? Yeah, it is, isn't it? And I just used the techniques that we used on problems 2 and 3 in the last part of the video. So I haven't done anything new, just adapted it to this equation. Good? Okay. So now, get all your x's on one side. So what are you going to do? Let's move the 1x, I agree, to the other side. And when you do that, what do you get? Good, you get 5x plus 6 equaling 4. And then move the 6 to the other side. And when you do that, 5x equals negative 2, because these guys are going to drop, just like these guys dropped. And then divide both sides by 5. So you end up with x equaling negative 2 over 5. Your answer is still a fraction. That's great, but I didn't have to deal with the fractions for too long in this problem. Good? Okay, let's see this problem. Fraction outside parentheses. This is a multiplication problem, right? So let's see what we get. Make the 6 into a 1. And if you need to write it off to the side, write it off to the side. You're doing 2/3 times 6 over 1, which will give you 12 over 3. And then you're going to distribute it to the x. So you're going to have minus, put a 1 under it, 2x over 3. And if you need to write it off to the side, then you write it off to the side. Yes? Okay. And on the right side, I don't have a whole lot to do because there's already just one fraction there, isn't it? Good. Okay. So what was my recommendation at this point after you distribute and you've got a bunch of fractions? What do you want to have? Yeah, let's get a common denominator, shall we? And the common denominator would be 6. So I'm going to multiply both fractions by 2, because that's how I'm going to get both denominators to be a 6. So then you end up with 24 over 6 minus 4x over 6 equals 4. And now all fractions have a common denominator. So the choice is yours. You can move things around at this point, or we can employ the technique that we use on problems 2 and 3 and problem 4. Because wouldn't this be a nice equation if those 6's weren't there? So what do you want to do? I agree. Get rid of them. So that means I have to multiply this entire side by 6 over 1, and the same with the right side. Remember, each of these fractions is going to get multiplied by 6 over 1. So when you multiply 24 over 6 by 6 over 1, yeah, that 6 is going to cancel with that one. And if you multiply 4x over 6 by 6 over 1, yeah, that 6 is going to cancel. Does that make sense? Okay, what remains on the left? 24 minus 4x. And on the right, yep, those 6's are going to drop also, which leaves you with the simple 5x. Doesn't it? Okay, how are we doing? Does it make sense to cancel those denominators once they're the same? Yeah, it's extremely simple to do. So why not get rid of them? Okay? All right, solving for x, what are you going to do? Yeah, get the x's on one side. So let's add 4x to both sides, which means you end up with 24, these guys drop, equaling 9x, and then, good, divide both sides by 9. Very good, which means you have x equals 24 over 9. It's a fraction. What do you try to do with a fraction when possible? Simplify. Can I reduce it? Yes, I can divide top and bottom by 3, because both will reduce by 3, which means you end up with 8 over 3 equaling x. Well done, you guys. Well done. So, little recap. Distribute when needed. Once you have a better idea of what the equation looks like, get the common denominator. And then since the denominators are all the same, cancel them away, because it makes nice, clean little equations for us to solve. And these types of equations we have solved plenty of times. Are we good? Okay, if you need to, rewind the video, go over 1 or 2 of these examples again as you need to. Have fun with it. Fractions aren't bad. Have fun with them. Conquer them. Don't let them conquer you. I'll catch you on the flip side.